Welcome to the DIY Honda Garage channel. This presentation addresses DTC P0657, which refers to a malfunction in the Powertrain Control Module, PCM, power supply circuit on the 2023 Honda Accord. The PCM is an essential component that manages various engine functions by controlling the fuel injection, ignition timing, and emission controls. When the power supply to the PCM drops below a specified voltage, the module interprets this as an abnormality, leading to the triggering of this diagnostic trouble code DTC. This malfunction can result from issues within the PGM-FI main relay circuit or the wiring connecting these components. Understanding the location and role of these components is essential for effective troubleshooting. The PGM-FI main relay is typically located in the engine compartment, and it connects the battery power to various engine control modules, including the PCM. DTC P0657 indicates a malfunction in the power supply circuit that provides voltage to the Powertrain Control Module, PCM. The PCM is responsible for regulating crucial engine functions, and if its power supply drops below a specific threshold, it triggers this error code. The core components involved in this malfunction include the PGM-FI main relay and the various wiring circuits that supply power to the PCM. The PGM-FI main relay, located in the engine compartment, plays a vital role in ensuring that the PCM receives proper voltage. A failure in this circuit can lead to engine performance issues such as poor acceleration, stalling, or even failure to start, emphasizing its importance for overall vehicle operation. Several factors can lead to the triggering of DTC P0657. First, a faulty PGM-FI main relay can prevent the proper voltage from reaching the PCM, causing a malfunction in the power supply circuit. Second, issues such as open circuits or shorted wires in the power supply circuit can lead to inconsistent voltage delivery to the PCM, triggering this error. Lastly, if all external components are working correctly, a malfunction within the PCM itself could be the root cause. Each of these potential issues must be thoroughly investigated during the troubleshooting process to isolate and address the cause of the problem. When DTC P0657 is triggered, drivers may notice several symptoms indicative of a power supply issue to the PCM. One of the most common signs is the illumination of the check engine light on the dashboard, alerting the driver to a potential issue that requires attention. Additionally, the vehicle may exhibit engine stalling or difficulty starting, as the PCM's inability to function properly affects engine performance. Poor acceleration can also be a consequence, as the PCM may not be able to optimize fuel delivery and timing without the correct voltage supply. Other symptoms may vary, but will likely reflect a direct correlation with the PCM's functioning. The first troubleshooting step requires starting the engine to initiate the diagnostic process. Once the engine is running, check the power supply voltage at the PCM. This is essential to determine whether the PCM is receiving an accurate voltage supply. The specification for normal operating voltage typically should be around 12 volts. If the voltage is found to be below this threshold, it signifies an abnormality in the power supply circuit, prompting further inspection of the related components, such as the PGM-FI main relay, to diagnose the root of the malfunction. In this step, perform the PGM-FI main relay 1 test to verify its functionality. Ensure that the relay is properly connected and operational. Also, inspect the external circuit, particularly the plus BIGP power supply circuit. This involves checking the integrity of the wires connected to FI main RLI out and FI main RLI CL. Look for any signs of damage, such as frayed wires or loose connections. Both open and short circuits can cause significant disruptions. leading to electrical failures. If the relay and wiring appear intact, proceed to the subsequent inspection of the PCM itself. Perform component connection tests by reconnecting components one at a time. This process involves reconnecting the PGM-FI main relay 2 and the PCM connector A while monitoring for continuity issues. Each component should ideally exhibit the expected behavior when reconnected, confirming that the circuit is intact. If any abnormalities appear, such as a lack of continuity or unexpected resistance, further troubleshooting is essential to isolate the fault. This step is crucial in pinning down electrical issues that might not be apparent during initial inspections. If all previous inspections indicate normal conditions, turn your attention to the PCM itself. If the PCM is suspected to be the root cause of the malfunction, thorough testing is essential to confirm this diagnosis. This may include checking for any internal faults that could cause improper voltage readings or malfunctions. Additionally, ensure that all components have been reconnected correctly during the preceding tests to rule out connection errors. This step is critical to ensure that all possible external issues have been addressed before concluding that the PCM is indeed faulty. Once the repair has been completed, it's essential to clear the DTC from the vehicle's system using the diagnostic tool. After clearing, run the engine again and perform various operational tests to check that the engine functions normally without re-triggering the fault. Monitor for any warning lights or signs of issues during testing. Successful repairs will stabilize the vehicle's systems and confirm that the PCM is now receiving the required power supply. This verification step is crucial to ensure that no further diagnostic trouble codes appear and that the vehicle operates as expected. To prevent future occurrences of DTC P0657, implementing a proactive maintenance routine is essential. Regular inspections of the vehicle's wiring and connections can identify potential wear or damage before they lead to significant failures. Additionally, routinely testing the PGM-FI main relay for proper operation will help ensure the electrical system's reliability. Performing comprehensive system diagnostics at regular intervals can provide early warnings of abnormalities that may develop over time. By maintaining vigilant attention to these components, owners can significantly reduce the risk of power supply issues in the PCM. In conclusion, DTC P0657 highlights critical issues within the power supply circuit that can significantly impact the vehicle's operation. Understanding how the PCM interacts with components like the PGM-FI main relay is instrumental in diagnosing and resolving these issues effectively. Diligent troubleshooting is crucial to accurately identify faults within the electrical system, ensuring proper functionality of the PCM. To mitigate future risks, regular maintenance practices should be implemented to keep an eye on potential weaknesses in the power supply circuit. Overall, awareness and proactive measures are key in maintaining the optimal performance of Honda Accords equipped with advanced electronic systems. Please like and subscribe to the channel. See you next time.